Hi there, I'm Charles Perine from Trend Micro. Welcome to Faking a Factory, creating and operating a realistic honeypot. We got this idea for creating a factory honeypot by seeing a bunch of news articles out there about attacks against different factories where the attackers installed ransomware on the different systems. So we wanted to create our own factory and see if we could catch anybody trying to do the same thing on our system. In order to do that, we needed to create a realistic ICS environment with proper layout, logic, equipment, and we wanted to be highly interactive, such that when somebody clicked a button on the HMI, there would be a real-world impact on our system that we were able to monitor. So the equipment that we picked up was a Siemens S7 1200, Omron CP1L, and two Micrologix 1100s. And we started to try to develop the logic and what our system was kind of before we had any idea what we wanted to do. And what ended up working best for us was actually creating the HMI first. And once we were able to create the HMI, creating the logic afterwards was a lot easier for us. So once we were able to visualize what our factory did, we were able to create our logic and program everything else in. So you can see here we have our HMI, which has an agitator up at the top with a tank, and that was controlled by our Micrologix PLC. We then had a process heater, which would take the product from the tank and heat it up. It would then pass that product onto the injector, which would mold it, and then it would drop it onto the conveyor belt, and that was monitored by our Omron. And then the product would continue down the conveyor belt. It would get inspected by an electronic eye, and then it would get dropped onto a pallet, and eventually once the pallets were full, the palletizer would move the devices off into a different location. So we wanted it to look as realistic as possible, and to do that, we tried to use real-world values. So myself and Stephen Hilt had both been consultants doing control system security in the past, so we used some of that knowledge. We also had some help from Thomas Van Norman, who provided us some other values that we weren't 100% sure of, and we set it up such that our system looked realistic. When you turned on the process heater, it didn't automatically go from room temperature to 400 degrees Fahrenheit. When you turned on a conveyor belt, it slowly started ramping up, and we wanted that realism in there such that somebody who kind of knows what they're doing or knows what they're doing as far as control systems isn't just going to say, oh, that's, you're full of it. It's obviously fake. So one of the things that Lord had to do was create some logic, and one of those was a random number generator. Some of the PLCs had random number generators built in, other ones did not. And we had to program those in order to get some of those minor fluctuations in temperature and the speed of the conveyor belt to work properly. So another device or another system that we had on our network was a robotics workstation, and it's actually the first workstation that we exposed to the internet. The other one eventually was the HMI that we exposed, but we started with the robotics workstation because it was a slightly lower value target. It also was a system that was designed to control the palletizer. So next we opened up some of the ports to our system, and those being the Micrologix, the Omron, the Siemens, and then we had a couple VNC ports that we opened up eventually on our HMI as well as on the robotics workstation. We decided to use VNC instead of RDP because VNC was a lot easier to monitor through PCAPs. We were able to analyze the data a lot better. You could see clear text, passwords being entered in or tried. We were able to get a lot more data out of VNC than we were out of RDP. So we then set up our company and we put some real addresses out there. We found a couple incubators that were good for industrial startups. And so you can see we mapped out a couple of the different businesses, one of them being in Chattanooga, the other one being in Los Angeles. And if you go on Google Maps, you can find some images of those buildings. And so if somebody were to do a deep dive to see if we were a real factory, it would look more like we were a real factory. Small, but real. We then set up some DNS entries for different locations, one of them being our factory, another one being our VPN, and another one being our website. So we had all those set up. So if somebody were to, again, investigate us further, they would see that we have a few different DNS entries out there, and maybe start poking around on some of the other IPs that we had. Next, we went to thispersondoesnotexist.com, and we created a number of employees. We had 4 employees total. The first one being Mike Wilson, who was kind of our chief maker, and he ended up being our IT guy, and we'll talk a bit more about him later. We also had Jans Fischer, who was our engineer. We had Emily Clark, who was our 3D modeler, and Stephen Murphy, who is our safety guy. So, another thing that we did is we set up a VoIP phone number such that if somebody wanted to get in contact with us, they were able to call in, and we had an automated receptionist and extensions to all the different employees. The company that we used was RingU, which is a friend of one of my colleagues. He set us up with that, and so we're thankful for that hookup. Next, we set up all the monitoring on the system. One of the really cool things with VirtualBox is that it allows you to do video recording of the screen. And we use those video recordings to basically watch what our attackers did to our system. It was an extremely helpful way to monitor the system outside of having some kind of tripwire installed or having other kind of file monitor installed. And it also allowed us to get deeper than just looking through the PCAPs. The next, we had a couple, 4 taps that we used. These were from SharkTap, and they were just Ethernet taps. They worked really well for us. Captured everything. I don't think there was any drop packets that we saw. So this is what our final network looked like. We have the HMI, the engineering workstation, and the robotic workstation on the left-hand side. Those are all VMs running on a laptop. We have the PLCs kind of in the right center, all hooked up, and we had taps across pretty much all of that, and they were all going into a Raspberry Pi. The Raspberry Pi would collect all that data, and then it would forward that on to another server that we had to process all those PCAPs. And for that, we used Moloch. Moloch is a AOL product. It's up on GitHub, free to use, and it worked really well. It allowed us to visualize our PCAPs, do traces, monitor the full conversations. We could extract files out. Worked really well for our purposes. It is typically set up for live capture, but you can also just upload PCAPs to it too, and it will work like that as well. Another thing that we did was we set up a bunch of scripts that would go through and process our PCAPs and just give us kind of generic data. who was talking to who every day, how much data was being transferred, the country of origin, stuff like that. And that just kind of helped us keep ahead of what was going on, or keep up with what was going on in our system. So now we get to the fun stuff. What happened on our system? A lot happened, and you'll see that there is actually a couple gaps here. The first one being the time that we went live to the time that we had an attack. And then you'll also see a gap kind of after the first ransomware attack that we had into resetting the virtual machines and kind of going live again. So we're going to break these down into kind of two larger sections. The section just after we started up until the reset, and then the section after the reset. So on May 6th, we went live. I think we had our VNC turned off at that time. And then nobody was really doing anything with our systems. They were just looking at, there were some scanners out there, automated scanners that were picking up our PLCs, but nothing happened. So then we put VNC on, opened up that port, but we made the VNC read-only. And we were hoping that somebody would exploit it, we would get something cool out of it. That didn't happen. So after a few more weeks, we opened up VNC on our robotics workstation, and we allowed people to do write access to it. So they had read-write access to that system and read-only access to our HMI. We also started posting some information on Pastebin, trying to leave little nuggets that our system was out there. Didn't really see anything come of that, though. So our first attack that we saw was a malware installation, and what happened there was somebody came onto our system and they dropped this host.exe, which was it's a version of Ares C2, which is available on GitHub. We were excited, somebody finally attacked us, and looking through the file, looking at everything, it ended up just being a Monero miner. So kind of lame. So next what happened, we had a bunch of minor things that came up. We had some phone fraud, some people turning on RDP on our system, minor issues that we didn't really, we looked at it, didn't really dive too deep into it. There was also people who liked to log off of our system for whatever reason. They just didn't like us having a system online. Then we get to our ransomware. And this ransomware occurs towards the end of September. And what we see is somebody finally logs into our system, installs some ransomware on it. We start, and we determined that it was a crisis variant. So we started talking to them. They wanted $10,000 to decrypt everything. We negotiated them down to about $6,000, and we wanted proof that they were actually able to go ahead and decrypt all the files that they had encrypted. So they had said that we could send them one file, but it had to be an unimportant file. So we went with one of the config files with all of the logic for our, I think it was for our Omron, and to see if they knew what they were dealing with when it comes to control systems. So we sent them that file, and they decrypted it and sent us back. So they sent us back a pretty high priority file, indicating that they didn't really know what they were dealing with when it comes to factories. We let that kind of play on for a week or so, and then eventually we did a reset on our virtual machine, set everything back to zero essentially, and waited for new attacks. So the next attack that we had was the what we called the not so advanced attack. And it was funny to watch this because the person went out, they downloaded an installer, and it was called shell.exe, and they got a warning from Windows saying that it could harm your computer if you open this up. And instead of just saying, selecting the actions and saying open anyway, they went and tried to disable Defender, and then they tried to download the file again, and same issue. Then they completely turned off Defender, and they still weren't quite able to get it installed. Eventually, they were able to get it installed through PowerShell, but it took them a little bit of time. And at the end, the guy had put up a nasty note to Mike, our IT guy, and calling Mike an idiot, and that he had been connected for 10 days, and that he had, I think, looking through our logs, he had taken about 13 gigs worth of our phony data. So no big loss, but he was kind of mean to Mike. So the next thing that we had a couple ICS attacks, but they weren't very critical. Somebody started up our factory a couple times. Didn't really do anything to it, but they started it up. We did have, and that was after we had switched our VNC from read-only on the HMI to read and write on the HMI. So next we had what we called the good guy hacker. And this nice person came in and wrote on our system that he had found our PC online and that anybody could connect to it, and that a hacker, might do bad things if they were allowed to connect to the system, and that we should really secure our VNC, at least put a password on it or something else. It was really nice of him. We appreciate it. And then we had something called Ransomware 2. It was another crisis variant. The next we had something that just is really, really weird, and we have no idea what the people were doing, why they were doing it. If anybody has any good idea, please let me know. But they went through and installed a Nokia emulator on our system. So they get access to our system, they go out and they download from GitHub Symbian OS emulator. They go and download Java as well as Perl. They install all of the Java and Perl, and then set up the Symbian OS, and then they browse to Google. And that's it. They then, what did they do? They deleted some of the Java, they deleted the Perl, and they removed the Nokia simulator, and that was it. So we're still at a loss. If you have any suggestions or any explanation, please let us know. One of the other things that we saw was what we called renameware. And this was a really kind of odd attack, because what happened is it's kind of lame attack. The person logged into our system and started using this script. It was a batch file. And the script goes through and it just renames everything in a directory. So I think it renamed it, filename.crypt. And we were actually watching this person live on our system, and we saw that the script that the person was using to do this encryption with had accidentally renamed the script. And so we saw the person go through and remove the .crypt from the end, change it back to .bat, and then continue on encrypting our files. So we determined, we looked at what the file had in its contents, and determined that all it was just, rename star dot whatever to star dot crypt. It was poorly done, but could be effective, I guess. And the person left a note on our screen. They wanted a few $100 to decrypt it. However, they didn't provide any email address, so we couldn't contact them. We couldn't talk to them. And all they left was a Bitcoin wallet for us to pay into. About 4 or 5 days later, after we didn't pay them, they came back. They deleted a bunch of our files, and then they set up our system such that on startup, it would open up a bunch of adult websites. So the last event I'm going to talk about is something that actually happened fairly early on. And this was when Viz, also known as Dan Tentler, got onto or found our system, found our honeypot, and was convinced that it was a real factory that was exposed online. He started an ICS cert case, and a friend of Stephen and myself, Mike Tucker, was contacted. He was looking through the system. He noticed that there was an Omron on there, and Mike reached out to Stephen on our team, who has a lot of experience with Omrons, and we told Mike that no, this is actually our honeypot that's out there, that shouldn't go any further. It doesn't need to be an actual ICS cert case. Contacted a couple other people, and eventually got on the phone with Viz, trying to show him that this is in fact a honeypot. And it took a bit of convincing. We actually had to write on the screen, "Hello Viz" or "Hi Viz," and to show him that this was actually our system. Viz then sent an email a bit later to ICS Cert and a couple other people that were involved, saying that it was the most elaborate honeypot that he's ever seen. And later on Twitter posted that, have you ever learned a thing where the immediate outcome has been, I need rum, like right now. So it's kind of a win for us. So the next part I'd like to go into is a little bit of the statistics as far as who was visiting our system and kind of where the traffic was originating from. So this first picture you'll see is all of the traffic that our system had externally. So anytime there was an external communication, so either from our system to someplace else or from someplace else to our system, that was the data that we were looking at. And the majority of it was in the US, quite a bit in Russia, Canada was pretty high as well, China. And then if you look through on the next page, we have just the robotic workstation and the HMI. And that's pretty much the same data, because most of our data was actually on the robotic workstation or the HMI. The next set of data is pretty much everything from the PLCs. So it didn't matter which PLC. This is kind of an aggregate of all the different PLCs. So Russia, China, a little bit from India, some from Japan, and Canada, and the US. Now, one thing that was interesting was looking at the individual PLCs. So if we look here at the S7, we see China and Japan, as well as the US and Canada were pretty big. Russia was a little less so. Then we have the Micrologics, which is pretty much the US, a little bit of Canada, a bit more in China, and a little bit in Russia, a little bit in the UK. And the interesting one that I found was that there's a lot going to the Omron, or a lot of Omron going from Japan and China, as well as the US. So let's look at a little bit of stats here, and we see that the total number of unique IPs was around 8,900 IPs. Of those, we found about almost 600 IPs that we could easily determine that were from scanners. That left about 8,300 unique IPs that were not from known scanners. Then we have the unique IPs per day. And so the reason that the unique IPs per day is different than the unique IPs that we saw in the previous slide is that these are if 1.1.1.1 connected to us on a Tuesday, and then that same IP connected to us on a Thursday, this is going to count both of them because this is kind of unique IPs per day, or unique sessions, I should say. So on the previous slide, it was if 1.1.1.1 connected to us just once, that would be counted in that 8,900 amount. So what we see here is about 85 unique IPs per day, and we had about 10 unique scanner IPs per day, and they would be from all different types of sources. We see Shodan, IP, a few other ones that are out there. So the amount of data that we had was pretty high as well. We had over 550 million packets were sent into and out of our system, and we had about 126.7 gigabytes that left our system. I think it was actually external data transfer was about just under 30 gigs. There was some internal data transfer that was happening as well, especially when people were looking and going through the files inside of our network. So a couple tips if you want to run your own honeypot. Remove any virtual machine identifiers. So going through the registry, looking for anything that says VirtualBox or VMware or Hyper-V. Just make sure that all of that is removed. Make sure you don't have the guest add-ons installed. That's a big key identifier. VirtualBox screen recording was amazing. Let us create all those really cool videos and actually see what people were doing on our system. You need to have good file and network forensics. For us, we use the VirtualBox screen recording as our main indicator for what files had been accessed. Again, VNC worked really well for this purpose because we could see what people were typing in. There were a couple of VNC keyloggers that you could use, and we didn't want anything installed on our virtual machines, so we wanted to do everything either over the network or through the VirtualBox screen recording. And then make your target interesting. It should be something that attackers want to go after. And that was one of the reasons why we chose a factory. We had seen previous attacks. We wanted to see more attacks and see what the attackers were going after and how knowledgeable they were of the systems that they were attacking. It turned out, for the most part, they weren't all that knowledgeable about the systems. So in conclusion, if you want to run a high interaction honeypot, you need to monitor it daily. It's something you have to pay attention to. You have to watch it and deal with incidents as soon as they happen. Don't wait, because otherwise the incidents just kind of pile up on top of each other, and eventually your honeypot will simply collapse. And the attackers seemed to be a lot more interested in having a clean IP to go out and do something. We had more, frauds and kind of other miscellaneous events happen than we did, proper ransomware or host infections. So that it seemed like they were mostly just going after a clean IP. Don't put your control system on the internet ever. Just don't do it. And it's striking to see how many control systems are available out there. It's a bad idea. Don't do it. And attackers are going to be mean to Mike, and they will hurt Mike's feelings. So, be prepared to have people yell at you for being an idiot for having your system online. I would ask a couple favors. If anybody is interested in running a honeypot with us as far as a control system or ICS style honeypot, please let us know. We're looking for other people to proper asset owners to get to talk to and try to run an actual honeypot within their network if they're interested in that. And please take a look at our report. We put this out in mid-January, late January. So take a look. If you have any questions, if you want some more information, feel free to reach out to us. We're willing to talk and potentially share information or just have a good conversation about kind of the different things that we saw and what may be of interest to you. So thank you all for your time. I appreciate it. Feel free to pass any questions along and have a wonderful day.